Okay, let's look at the Alkane family. The Alkane family. In the previous class, we talked about, we discussed extensively, right, on the terms used in what? Organic what? Chemistry. And we defined the term organic chemistry as the study of carbon compounds, right? The study of how carbon combined with itself and other elements to form a long chain or a branch chain at the carbon. We have discussed about that in our previous class. Then we also talked about some terms. We looked at the word homologous series, isn't it so? The word catenation, the word saturated and what? Unsaturated hydrocarbon, right? Then also look at the possible bonds that are found in organic compounds. We have two types, which are the pi bond and the sigma bond. Were you there? Wow. How many of you were in the class when I taught that? Okay. So maybe the makeup class I will repeat. But today we are looking at one of the homologous series, which is the Alkane family. We say Alkane is an homologous series. One of the homologous series is what? Is Alkane family. We have the Alkane, the Alkanes, the Alkanes. I will say that the Alkane, they are saturated hydrocarbon. When you do what Alkane, please, I've started. Alkanes are what? Saturated hydrocarbon. Meaning that they have how many bonds? Single bond. They are single bonded. Okay? And they have how many sigma bonds? They have 4 sigma bonds. If I have this, for example, each carbon in Alkane has 4 sigma bonds. If we have this, we have this. Single bond, single bond, single bond, single bond. Single bond means what? Sigma, right? Sigma, sigma, and sigma. Are you there? Now, whenever I see a compound that has all the bonds that represent the compound as single bond, that compound represents what? It's called what? An Alkane. Are you there? Then you will now ask yourself, what member of Alkane is it? Is it the first member, second, third, or fourth? You know, the first member of Alkane is what? Is what? From the word met, Abi? Met, then we have to add what to it? A-N-E. Are you following? The first member, when N is 1. What is the second member? X. Which is what? A 10, Abi? Third is what? O. Which is what? O 10. Fourth is what? Fourth. Which is what? O 10. What is my fifth? Pence. Which is what? Pentane. 6 is what? X. Which is what? Xn. 7 is what? Ept. Which is what? Heptane. 8 is what? Oct. Which is octane. 9 we have non, which is nonane. 10 we have dec, which is decane. These are the first 10 members of the Alkane family, isn't it so? For methane, the general formula we know is CnH2n plus 2. Alkanes have the general what? Formula. So for the first member, that means when n is 1, right? That will be what? CH4. Let's check it out. N is 1, Abi. H, we have 2 times 1 plus what? 2. That will give us what, yeah? CH4. Okay, for this, what do you have? C2. H, 2 times 2 is 4 plus 2, 6. The third one will be what? C3. H8, Abi. What will be the fourth one? C4, H10. This, C5, H12. Just like that. Is it not so? Now, why do we say Alkane? Alkane family, they are homologous. Each of the members of Alkane differs by what? By CH2. If you look at this and this, the difference is what? 2. CH what? 2. Do you know why? If I'm to add CH2 to CH4, I will form this. When you add this to this, I will form this. When you add this to this, I will form this. So each member differs by CH2. So they are what? Homologous over series. Right there. Now, in a compound, we have 2 things that defines the compound, right? We can have what we call the functional group and the what? The alkyl group. Are you there? If you are asked to define what is the functional group of alkane, it's the single bond. The single bond represents what? The functional group. The functional group is what determines the main chemical what? Properties of that compound. For example now, if we have this ROH, we know this is what? Alcohol, right? The functional group is what? Is OH. Why R is what? Why R is what? The alkyl group. We have the alkyl group, and we have what? The functional what? Group. Is it making sense now? So, if I'm to talk about the functional group for alkane, for methane, for instance, that simply means I will look at this bond here. This single bond represents what? The functional group. The 1, 2, 3 represent what? Methyl. Do you get? You know, every compound must have alkyl and what? Functional. For this compound, R represents the alkyl. The alkyl here is what? CN, H2N plus 1. O what? OH. Is it not so? So for this is the functional group. For example, let's say if N is 2, what will it be? C2, H what? 5. O what? OH. Abi? So OH represents what? Functional group. Why C2H represents what? The alkyl group. And this is called what? Ethyl. It's called what? Ethyl. Why is it called ethyl? Because carbon is what? Is 2. Either. So for this, if I'm to bring that, if I'm to say that, if we are saying that every compound has a functional group and alkyl group, for that of methane, what do you think will be the methyl group, the alkyl group? 1, 2, 3 is the alkyl group. Why this represents what? The functional. But this stroke here is part of what? The bond that defines what? This methane. Is it not so? If I have the hydrogen, so a functional group for all alkane represents what? Single bond. For alkane, what's the functional group? Double bond. For alkyne is what? Triple bond. Do you get the concept now? Functional group simply means when you look at the compound, you will know what that compound represents. Once you say anything OH, you know it's what? An alcohol. When you say anything RCOOH, you know it's what? A carboxylic acid. Do you get what I'm saying? So what will you see in alkane that defines alkane is the single bond. Do you understand? You know, if I should combine this now with another carbon, that will give us what? Another alkyl, abi? Are you seeing this now? So between this now, what's the functional group here? Is this single bond here? So I have alkyl here, I have what? Alkyl here. This is called methyl, right? This is under what? Methyl. Is it making sense now? So likewise, other compounds and all that. Now let's put this down. Let's define alkane. Alkane are hydrocarbon. Alkanes are what? Hydrocarbon. Or they are saturated hydrocarbon, sorry. Alkanes are saturated hydrocarbon. Containing single bond between the atoms. Containing single bond between what? The atoms. Containing single bond between the atoms. Are you there? Containing single bond between what? The atoms. They are also known as paraffins. They are also known as what? Paraffin. I know you've heard about paraffin oil. Good. Paraffin. They are also known as what? Paraffins. Are you there? Alkanes are sp3, sp3 hybridized. Alkanes are sp3, sp3, hybridized. That means the carbon atom in alkane are what? sp3 what? Hybridized. Huh? Have you learned hybridization here? Yeah? No. Okay, when we have a large class, I will teach that, okay? So we can see the orbitals, how this is being formed, okay? But alkanes are what? sp3 orbitals. The word sp3 means one s orbital plus one p plus one p plus what? One p. How many p do we have here? 3p. The s orbitals represent a sphere. Yp represents what? This. Either. So when you combine this together, when you combine one of these with three of these, that will form what? sp3. Okay. Now, every sp3, let me not go into the, I will teach hybridization as a topic, Alright, they are what? sp3 what? Hybridized. Now let's look at the next thing I want us to look at is, now we have seen the general formula of alkane, right? As well, CnH2n plus 2. Is it clear? Now on our own, we can bring out the first 10 members. Is it not so? Okay. We have two types of bonds. We have what we call the sigma bond. The sigma bond. Sigma is this. Then we have what we call the pi bond. The pi bond. Your normal pi symbol. Sigma bonds are called single bond. Either the first bond carbon links with itself or other elements is what? Sigma bond. For example now, if I have this, the first bond carbon links with itself, maybe with carbon, or with other elements is what? Sigma. Also here we have what here? Sigma, right? We have what here? Sigma. Here's what? Sigma. Here's what? Sigma. And here's what? Sigma. Isn't it so? So if I'm to complete this, we have hydrogen. This is called ethane, Abi. Ethane has how many sigma bonds? 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. 7, right? 1, 2, 3, 4, 5, 6, 7. Yes, 7, right? Yes, I'll give you a formula to check that. Now, we have 7 sigma bonds in this. Sigma bonds are strong bonds. They are what? Strong bonds. That means any compound that contains sigma bonds has less reactivity. Either has what? Less what? Reactivity. Unlike alkanes. How do you know alkanes? Alkane has what? Double bond, Abi. If I have carbon, I have carbon. This is an alkane. Is it not? Is it not? Okay. This is an alkane. Alkanes are formed from the parent alkane when there's a loss of 2 hydrogen atom, Abi. So if we have this, here we have sigma, we have sigma, we have sigma, we have sigma. One of these bonds, say the first bond, carbon links with itself is what? Sigma bond, Abi. Then the other one is what? Is pi bond. Are you there now? So for alkane, for this 18 has how many sigma bond? How many? 5, Abi. How many pi bond? 1 pi bond. Are you there? If you look at that of, let's say, alkane is how many bond? Triple bond. Alkane are triple bonded. Yeah, we're going to have hydrogen. Have what here? Hydrogen. What do you notice here? Let me show you something. For ethane, there's a complete hydrogen atom, Abi, that surround what? The carbon. But for this, once we introduce 2 bonds here, there will be a loss of what? 2 hydrogen atoms. Are you seeing it now? For this, what happened here again? I introduce what? Another 1 bond, Abi. There's also what? A loss. Are you there? So 1 bond represents 2 hydrogen atoms. So the more we introduce more bonds, the more the hydrogen atom disappear. So for this now, how many sigma bond? Let's take 1, 2. How many will be here? Is 1. The first bond is always what? Sigma. How many pi bond? 2 pi bond. Is it making sense now? Now there's a formula I gave to find the number of sigma bond. Number of sigma bond. Let's verify with this. How many carbon do we have here? 2. If the number of Number of carbon here is what? Is 2, abi? 2 minus what? The formula says what? Minus 1 plus what are other atoms? How many are there? 1, 2, 3, 4, 5, 6, abi? Plus 6. And that will give us what? 1 plus what? 6. What's the answer? 7. We have 7 sigma bond, right? Is that correct? So for this, let's check. Number of sigma bond is what? What's the number of carbon here? It's still 2 minus 1 plus what are other atoms? How many are there? 4. And that will give us what? 1 plus 4. That will give us what? 5. Is that true? Yes, 1, 2, 3, 4, 5, right? Okay, let's verify for this. Number of sigma bond equals what? Number of carbon is what? Is 2 minus 1 plus other atom is what? Is 2. So here will give us 1 plus what? 2. How many sigma bond? 3 sigma bond. Is it making sense now? So 1, 2, and 3. Even if there's a compound of this kind, although there is not. Let's say I have 1, 2, 3, 4. Is there any compound like this? No. But even if there is, that means that the first bond is what? Sigma. How many pi bond? 3 pi bond. Are you getting this now? Is it making sense? Okay. Now we have seen the bonds we have and all that. Now sometimes they will give you this in the exam. You know, here is Alkane, abi? This is an Alkane, right? This is Alkane, right? This is what? Alkanes. Are you following? And this is what? Alkanes. Alkanes have what? More pi bond, right? Followed by what? Alkanes. This one has no pi bond. They might ask you which of this compound has more reactivity. Alkanes. This reacts more than this. This reacts more than what this. The more the pi bond, the more the chemical reactivity of the compound. Is it making sense now? So in case they ask, use that, okay, to explain to them. Now let's look at nomenclature, subheading. Any questions so far on this? Nomenclature of Alkane. There are 2 major what? Systems of naming organic compound. Number 1, the tribal system. Number 2, the IUPAC system. The word IUPAC means what? International Union, Pure and Applied Chemistry, right? Okay. But the most acceptable system is what? Is the IUPAC. The tribal system is like the common name of the compound. Are you there? Note that organic compound can be what? Represented using what? Strokes. Using strokes. Using what? Strokes. Using strokes. Are you there? Let me give you the procedure in naming Alkane, right? Procedure in naming Alkane. Subheading, procedure in naming Alkane. You should have the idea, right? I believe you know the procedure. Number 1 is that identify the longest continuous chain of carbon atom. Identify the longest continuous chain of carbon what? Atom. Identify the longest continuous, it will be continuous. The longest continuous chain of what? Carbon atom. Number 2, are you there? Okay. Either. Number 2, number the chain so that the substituents. Number the chain so that the substituents. Number the chain so that the substituents. The substituents get the lowest possible number. The substituent gets the lowest possible what? Number. The lowest possible number. Number 3, name and arrange the substituent alphabetically. Name and arrange the substituents alphabetically. Name and arrange the substituents alphabetically. Are you there? Use prefixes. Use prefixes. Such as. Use prefixes. Such as di, tetra, di, tri, tetra. Okay? So, sorry, for repeated groups. Di, tri, tetra for repeated what? Groups. 4 repeated groups. Yes, for repeated groups. The last one, Numbers and substituents. Numbers and substituents. Numbers and substituents are separated from the name. Numbers and substituents are separated from the name using an hyphen. Using an what? An hyphen. Using an hyphen. For example, yes, we have 3 methyl, let's say butane. Are you seeing it now? You must have to separate the number and the what? The alphabet. Using what? An hyphen. Now we'll say that organic compound can be what? Represented using stroke, Abi? Right? Using strokes. Now let me explain that. Let's look at this. If I have this kind of, let's say this, and we have to identify this compound. First, we have to check what class of organic compound does this belong to, right? Are you there? This is an alkane family. Do you know why it's an alkane family? Each of these bonds is what? Single bond. Are you following? The edge represents what? Carbon what? Atoms. So we have how many carbon? Let's count. 1, 2, 3, 4, 5, 6. And 6 represents what? S. Abi? And that's called what? Zen. So this compound is called what? It's called what? Zen. Is it making sense? What if I have just only a stroke? What's it called? A 10. Why? 1, 2. Are you following? But let's just go this way. What do you call this? 1, 2, 3, 4. 4 is what? Huh? 4 is what? Boot, which is butane. Are you following? Okay. Now when it comes to this now, look at this. Like I say, before we can name, identify the longest what? Continuous carbon what chain. Isn't it so? You ask yourself, which one is the longest continuous carbon chain? From here, right? Let's count. 1, 2, 3, 4, 5, 6, 7, and what? And 8. Is it not? This stroke here that emerges from here represents what? A key. Represents what? A key. This is a branch. Are you following now? Although we say that a stroke represents, this represents what? A 10, but when the stroke becomes a branch, it becomes what? An archive. It's like saying, for example, now let's say if I have this CH3, CH2, let me use a normal compound. Watch. Let's say we have this to be hydrogen. Yes, hydrogen. Yes, hydrogen. Here we have CH3. I see the logic now? Here is what? Hydrogen, 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 and hydrogen. Now watch. 1, 2, 3, 4, 5, 6, 7, 8. Let me check. 1, 2, 3, 4, 5. Okay, it's not the same. Let's continue, right? 1, 2, 3, 4, 5, 6, 7, 8. So hydrogen, 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 and hydrogen. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These two compounds, they are the same. Are you following? Are they the same? 1, 2, 3. So this should be here, right? Sorry. This should be CH3. Is it making sense? So the using stroke to represent this is in this form. Are you there? So this and this, they are the same. So this CH3 now represents what? Just a stroke. Is it making sense now? If I have this here, let's say I have another stroke here. This represents what? 2 methyl. That means what will be here? Is what? CH3. Is it making sense now? Okay. What if we now have something like this? This represents what? A teal. Now after met, it's what? It's air. Abi? That means that on this other side, I will have what here? C2H what? H5. Are you following? If I have this represents what? Propyl. This is what? Butyl. Is you get what I'm saying now? So for this, what if we have this? Let's say we have this way. This will represent what? Two ethyl at the same time. Is that not so? Now let's watch. Let's name this compound first. Okay, I've altered the whole thing. Let's go back to the first one we have. If I have a stroke here, let's watch. 1, 2, 3, 4, right? 5, 6, 7, 8. If I'm to count from here will be the longest, Abi, to the what? To the branch chain. Is it not so? So the shortest carbon to this branch chain is what? Carbon 3. If I'm coming from here, it's 1, 2, 3, 4, 5, 6. Here will be 6. Between 6 and 3, which one is longest? Which one is shortest rather? 3. So I will use what? 3, Abi. It means I will start from here. So this becomes what? 3-methyl. Are you seeing what I'm doing? What the parent chain? Octane. Is that 8? Octane. Do you understand what I'm saying? So the first is to identify the longest continuous chain. Identify the longest continuous chain, Abi, which is what? Octane. Is it not so? Are you there? Then when you now identify it, then you look at your substituents. Is in what carbon here? Carbon 3. Are you there? And this substituent represents what? Methyl. Are you following? So here, methyl falls in what carbon? Carbon 3. So we have 3-methyl what? Octane. The same thing with this, right? Let's look at this. Now let's look at this. Let me remove this here because I will give you some other principle. Look at this. This case now we have how many methyl? So that will give us what? In what carbon? Carbon 3, right? 1, 2, 3. We have 3. Are you seeing it now? Your hyphen. When you after writing your number, always put what? An hyphen. Di what? Dimethyl octane. Are you following? Is it making sense? We have 3,3-dimethyl what? Octane. Yeah, because we have one alkyl group here, right? CH3. CH3 is called what? Methyl. It's also called what? Methyl. So CH3, both of them form the what carbon? Carbon 3. So one of these 3 represents this. This represents what? This. So 3,3-dimethyl octane. Is that okay? If we have this kind of compound, look at this way. The first thing we need to do is to find the longest continuous chain, Abi. Is it not? Let's take. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Abi? Let's take this. 1, 2, 3, 4, 5, 6. This is 6. Let's check this. 1, 2, 3, 4, 5, 6. So which is the longest? 8, 9, Abi? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you get the concept now? You didn't get it? You didn't get it? You didn't get what I just said now? Try to explain again. With the longest, we have a branch here, right? And that branch here. This branch is practically what? I think it's ethyl. This is what methyl. Are you there? Don't call a branch until you have gotten what? The parent chain. That branch can even be the parent. Do you know what I'm saying? I'll give us some example. You said a branch can also be what? A parent chain. Now look at this now. 1, 2, 3, 4, 5, 6. From here to here is what? Is 6. Let's take from here. 1, 2, 3, 4, 5, 6, 7, 8. Is it making sense? Are you seeing it now? Let's come from here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So which one is the longest? You know we have 8 also, right? Will I choose 8? So 9 is the longest bar. So non-name, 9. From the word non, Abi, then we have non-name. Are you following? The parent is non-name. Now, if the parent, if here is non-name, that means any other one becomes what? The substituent. You will not take. Let's count. Let's take. Here's 1, Abi. 2, 3, 4, right? We have what? 5, 6, 7, 8, and what? 9. From here, let's take 1, 2, right? 3, 4, 5, 6, Abi. 7, 8, and what? And 9. From this region, you know, we say, while naming, the subtract groups are arranged what? Alphabetically, right? Is it not so? Between methane and ethane, which one will come first? Ethane, ethyl rather, right? Between ethyl and methyl, ethyl will come first, right? Before what? Me, right? Is it not it? E before M now. So ethyl will come before what? Now let's go. Look at this. We have 1, 2, 3, 4. This is 4 words. 4 ethyl. 5 words. Methyl. 4 ethyl. 5 methyl. What are the parents? No name. Let's take from this way. Can we take from this region? Here we have 1, 2, 3, 4, 5. Abi? Is it not? 5. This is on 6. Can we say it is 6 ethyl or so? 6 ethyl. What will be here? 5 what? Methyl. Nonene. Which one is the answer? If you look at this, let me show you something. Listen. These two obey the principle of what? Of the alphabet, Abi? That E will come before what? M. Is it not so? Now, when you have a case like this, where both of them obey, you will not take what? The order of the numbering. Numbering must be what? Must be increasing from the lowest to what? To the highest. Are you following now? What's the lowest here? 4. Followed by what? 5. So this compound is not correct. This is the what? The correct one. Are you following now? Is it making sense? The lowest possible carbon is the first. So 4 ethyl, 5, place your hyphen, 5 methyl, nonene. Yes, ask the question. 4, no. It's 4 ethyl, 5 methyl, nonene. Not 4, 5 ethyl, methyl. No, you don't do it that way. Okay? We attach this 4 to ethyl, attach 5 to methyl, then the parent's name, nonene, right? Okay. Are you following? Hope you're enjoying the class. Alright guys, let's look at these compounds here. Okay. So here we have, look at this compound. The first one we have here. What's the longest continuous chain? 1, 2, 3, 4, 5, 6. 6 represents what? S, Abi? Okay. So, the parent's name, we know it's Zen, Abi? Okay. Now, if it's Zen, let's count. Let's take 1, 2, 3, 4, 5, and 6. Is it not? No need of coming here because this is longer than this, right? So let's go. This stroke represents what? Methyl. What about this? Methyl. So you have how many methyl? So what will be the answer to this? It's 2, 3. Dimethyl ethane, right? Good. What about this one? This is 2, 3, 3. Trimethyl. Good. For this, 2, 3, 3. Trimethyl. What's the parent's name? The same as them? Okay. What about this? is hexane. 1, 2, 3, 4, 5, 6. 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Abi? This is 7, right? So let's count it. Let's what? 2. 1, 2, 3, right? This is methyl. This is what? Ethyl. So which becomes first? Ethyl. But let's look at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Even from here, it's still 4. Hope you're aware. So that will give us what? Let's go. 4 what? Ethyl, 3 methyl, The parent name is what? Heptane. It's clear, right? This compound what the parent's name? This way, right? Okay. So let's watch. 1, 2, 3, 4, 5, 6, 7, 8, right? So what's the name of the compound? Huh? These two, are they the same? Huh?
4 and 5.
This substituent group here, is it same with this? So why are you not saying 4, 5 die? Huh? Is it what? 5 ethyl, 4 what? Propyl, Octane. You're saying what? 4 what? Is this ethyl? Okay, let's watch. 1, 2, 3, 4, 5, 6, 7. Now, listen, let me help you. 8. It's always good to take it this way. Then this way, you not take which one is the correct answer. Are you following now? Now we have 2 substances, right? Propyl and what? Which one becomes first? Ethyl. Let's go this way first. 1, 2, 3, 4. 5, Abi? This is 5 what? Ethyl. This is what? 4 propyl. What's the parent's name? Octane, thank you. Now let's come this way. This way will be what? 4 what? 4 what? Ethyl, 5 what? Propyl. Octane. Now choose the answer. Second one back. Some of you, those at the back heard it. You got the answer. Do you get the concept? Don't just look at this compound from one side. If not, you will feel it. Bring it out from this side, also from this side. Then you look at the order of the numbering. Do you get? Both of them are actually accurate. Ethyl, right? But 4 should come before what? Before 5. Is it making sense now? I don't go. Because ethyl must come first. Alphabet takes superiority over what? Numbering. Do you get what I'm saying now? Alphabet takes what? Superiority over numbering. Now let me give you this now. I hope you are learning. Okay. Oh, I got this class. I didn't class. Ah, that's good. Oh, yeah, tell me this. Now, logically, you know, from the rule I gave you in numbering, we say that if we are to name a compound, we look out for the carbon atom, right? That bears what? The substituent group, abi? The closest carbon what? Atom. The closest for this compound is from where to where? From 2. It means your naming should come this way, not this way. Let's look at this. 1, 2, 3, 4. Abi? Are you there? This is 4 what? Ethyl. This is shortest. Is it not so? Is it not? Is it not? Let's watch. 1, 2, 3, 4. Abi? Now, this one here, from this way, is 4. It's also 4 from here. You get? You consider this way first, Abi? And this way. We now use what? From 4 to 5. Meaning that since both of them, since the shortest carbon is on 4, also on 4 here, we consider what? The decrease, the increasing order of numbering. For this, it is an error picking your numbering from here. Because the shortest carbon to the branch chain is what? Carbon what? 2. Is it making sense a little now? Let me come back to this now. Watch. I'm recording because I will post this. Please pay attention. The shortest carbon to this compound is what? To the branch chain is what? From this side is 4. Abi? Yes, also what? 4. There's a confusion on this. So we don't really know where to choose from. But the only way out now for this is when you start from here, we have this, Abi? From here we have what? This. Do you know what I'm saying now? Now we now look at what? The increasing order of numbering, which is from 4 to what? To 5. This gives us the accurate what? Answer. Then for this, the shortest carbon to the branch chain is 2 on this side. But on this side is what? It's 4. Is it making sense? Here is 2, here is what? 4. Or making sense? So that means I will consider this region, not this region. This way. Because the shortest carbon is what? It's carbon 2 now. Are you following what I'm saying then? So now let's go. Let's bring it out again. Let's go. Yes, so 1, 2, 3, 4. Abi? 4 what? 4 what? 4 ethyl. 2 dimethyl. 1, 2, 3, 4, 5, 6. What? Zen. Please, is it clear now? Is it clear? I said your alphabet takes precedence over what? The numbering. Do you get the concept? Alphabet takes what? Precedence over the numbering. Alphabet takes charge over numbering. We have a case like this whereby the branching from this region is 2. Yes, not on 2. It's on what? It's on 3. Are you getting the concept here? So what do we do? Here becomes, we have 1, 2, 3, 4, 4 what? Ethyl, 2 dimethyl ethane. If I'm to come from this region, we have what again? Let's look at it again. What do you have? 3 ethyl, Abi. 5 what? 5, sorry. Di what? Methyl ethane. Do you know what? There's an error in this one. We are not looking at the shortest carbon. We assume what as the shortest here, carbon 3. Are you following? If I'm to use this, that means we are saying that the shortest carbon to the branch chain is what? Carbon what? Carbon 3, which is not true. But rather is what? Carbon what? 2. Do you make it? Are you there now? So I can use this. This is called academic what? Suicide. Yes, ask your question. Well, let me give him. This one? In the answer. If we have methyl here. Okay, I'm coming. 4 ethyl. 5. Okay, 5 methyl. Octane. Okay, what's the question? It's still this now. Your air will come before me. They are still sharing the same equal whatsoever. 1, 2, 3, 4 from here. 1, 2, 3, 4 is from here. This is correct. Do you get it now? Okay. Let's look at this again. Let's go. 1, 2. The shortest is on one side. On 3, Abi. Yeah, it is long. I don't even need there at all. I can only need there if the shortest is 3. Do you get the concept now? Now let's go now. Let's look at this. What do you have here? 1, 2, 3, 4. Abi. 4 what? This is ethyl. Is it not ethyl? 3 what? Methyl. Heptane. But from here, it's too long. Even though the numbering is increasing, Abi. Are you following now? But there's an error here. What's the error? We are considering what at the shortest. 4 at the shortest, which is wrong. Is it making sense now? Okay, please. This is the accurate one. Oh yeah, name this compound for me. What will you do first? Identify the longest continuous chain. Name this. 9. From where to where? Is it this way to here? Oh, awesome. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it not? Let's come from here. Let's check. 1, 2, 3, 4, 6, 7, 8, 9. Ba? A stroke represents what? Methyl. So how many methyl do we have there? 3 methyl, Abi. The first methyl is in what carbon? Carbon 3, Abi. Do you get the concept now? Okay. Do you have ethyl there? Propyl, Abi. No ethyl. So between mer and pro, which one will come first? Mer, right? Oh yeah, who can tell me now? I'm giving you. 3, 4, 6, trimethyl, 5 propyl. Clap for yourself. So no matter how complex it is, you can do it, Abi. Okay. What if you're right. What if there's something like BR here? BR. Guinea corn was it? Bromine is what? 2 guinea. Bromo. 3, 4, 6, trimethyl, 5 propyl nonane. Clap yourself again. I just coming. Oh, it is well. Who can name this compound? Huh? No. Also, give me. Try methyl what? Eze. Wrong. What is the longest chain? How? From where to where? 1, 2, 3, 4, 5, 6, 7. By rotation, this is the longest. You are forgetting you are counting the longest chain. 1, 2, 3, 4, 5, 6, 7. Whenever CH3 is at the last carbon, you don't take it as the longest. As a substituent. Do you get the concept now? Hey, thank God for this example. And this is what the institute will give. You can like the 1, 2, 3. To your mind, you have already gotten it. Well, tell me the answer now. The shortest chain is on this side, Abi. And now, 1, 2, 3, 4. 4 ethyl. You're not getting it. 4 what? Ethyl. 3 methyl heptane, Abi. Thank you. Yes. Which one? This one? This one? If it's what? Yes, if it's the first in any compound, you don't take it as a substituent. You have to start numbering from here. Do you understand what I'm saying? Look at it very well. The longest is from here now. I'm still counting carbon. 1, 2, 3, 4, 5, 6. I can't stop here. It's 7. Do you get? For ethyl, let me get your question. Me, if I have ethyl, yeah? You still count the carbon, yes. At 2, yes. Thank you. Meaning, listen, see what you're saying. Let's say if we have C2H5 here, I'll still count from here because where is at the last carbon? To be 1, 2, 3, 4, 5, 6, 7, 8. Do you get the concept? So, what I say alphabetically, are you there? Listen, no. Listen. Alphabetical arrangement does not concern your prefix, your die, try, and the rest. If you look at this now, D should come before what? E, Abi? Don't say because D you come E, you now say 2, die. What you're looking at here is the E and what? And the M. Is it making sense now? Okay. So don't go and say because D is first, you now say die first. Okay, when you hear the word isomers or isomerism is the existence of what? 2 or more compounds, right? With the what? With the same molecular formula but different structural arrangements. Are you there? Are you there? Are you writing? Oh, you are right. Isomerism is the existence of 2 or more. Is the existence of 2 or more compounds. With the same molecular formula, but different structural arrangements. With the same molecular formula, but different structural what? Arrangements. Compounds that exhibit isomerism, they are called what? Isomers. Compounds that exhibit isomerism are called isomers. A good example, not even under Alkane, I'll give us Alkane family. We have ethanol and methylmethane. Now let's go into isomers of Alkane. Please write, note that the first 7 members, so the first 3 members, The first three members of Alkane, the first three members of Alkane as isomers of what? 1. The first three members of Alkane, are you there? As what? Isomers of what? 1. In finding what? Isomers of Alkane. From carbon 1 to carbon 7, the trick in finding this isomer is simply number of carbon. Let me get the formula I gave. Okay, 2 raised power n minus 4. Thank you. 2 raised power what? N minus 4 plus 1. 2 raised power what? N minus 4 plus what? 1. Where n is what? The number of what? Number of what? Carbon. Are you there? This formula only valid for the first carbon to the 7th what? Carbon in Alkane. First to 7. But the first 3 has what? 1 what? Isomer. And I'll show you. Just pay attention. For this, listen. First means what? Methane, abi? Followed by what? Ethane, propane. Meaning from methane to what? To heptane. Formula that you can use. Then for this, for carbon 8, the trick is simply 2 raised by n minus 4 plus 2. For carbon 9, the trick here is 2 raised by n minus 4 plus what? 3. I'm making sense, Uba. Are you seeing where I'm going? This one, from carbon 1 to 7 is what? 2 raised by n minus 1 plus what? 1. Minus 4 plus 1. Yes, what? The same thing, but plus what? 2. Yeah, for carbon 9, plus what? 3. Then for carbon 10, to be 2 raised by n minus 4 plus 1 plus what? N. Just put these formulas down. Let's look at this. Do me a favor. Create this table for me. Write something like number of carbon and number of what? Of what? Isomers. Huh? Number of carbon, the first is what? 1, abi? 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. I hope you are seeing the board. Huh? You're not seeing the board. Okay? Please see, okay? We say the first 3 members of Alkane as amino isomers. So here we have 1, we have 1, we have 1. Let's take the formula I gave us. For carbon 1 to carbon 7, right? Formula is what? 2 raised power what? N minus 4 plus 1. Do you know why they all have 1? If I'm to put the number for n equals to 1, what will be here? 2 raised power what? 1 minus 4 plus what? 1. Abi? Now we're 2 raised power what? Minus 3. We don't represent a negative answer as for number of what? Isomers. So I will just destroy this and use what? 1. It's a trick. Are you following? Likewise that of what? Carbon 2. What's carbon 2? 2 what? 2 raised power what? 2 minus 4 abi plus 1. Here will give us what again? Negative abi. We cancel out this and use what? 1. Are you seeing it now? For the third carbon, hope they are seeing the board from there. You're not seeing the board from there. Are you seeing the board from here now? For the third carbon, when n is what? 2 raised power what? 3 minus 4 plus 1 abi. Here will give us what? 2 raised power what? Minus 1 plus 1. Since this is negative again, what do we do? Cancel out. What do you have again? 1. Now let's try out when n is what now? 4. Now you are saying this one, you say the first 3 members has what? 1 isomers. So when it's 4, what do we have? 2 raised power what? 4 minus 4. Plus what? Somebody? 1. What's 4 minus 4? 2 raised power 0 is what? So 1 plus 1 is what? 2. So this has amino isomers, 2 isomers. Is it making sense? So when it is what now? When it is 5, let's go. 2 raised power 5 minus 4 plus 1, right? That will give us what? 2 raised power what? 1, is it not? Plus 1. What's 2 raised power 1? Is 2. 2 plus 1 is what? 3. So this has amino isomers, 3 isomers. For what carbon now? Carbon 6, Abi? Yes. What's carbon 6? Let's go. 2 raised power what? 6 minus 1 plus what? 1. Oh, sorry, minus 4. That will give us what? 2 raised power what? 2 plus 1. What's 2 raised power 2? 4 plus 1 is what? What do we have here? 5. What about 7? 7 still falls from carbon 1 to 7, Abi. The same formula, right? And that will give us what? Let's go. 2 raised power what? Minus 1 plus what? 1. Minus 4, sorry. I don't know what's, am I using minus 1? Okay, that will give us 2 raised power what? 3 plus 8 plus 1. 2 raised power 3 is what? 8. 8 plus 1 is what? What's the next one? Carbon 8. I gave the formula for carbon 8, Abi. What's for carbon 8? 2 raised power n minus 4 plus 2. And that will give us what? 2 raised power. What's that n here? 8 minus 4 plus what? 2. We have 2 raised power what? 4 plus 2. 2 raised power 4 is what? 16 plus 2 is what? 18, Abi? Here we have 18 what? Isomers. Wow. What's the next one? 9, right? 2 raised power 9 minus 4 plus what? 3, right? You are aware? That will give us 2 raised power what? 5 plus what? 3. What's 2 raised power 5? 32 plus 3 is what? 35. The last one is what? When n is 10. We have 2 raised power what? N minus what? 4 plus 1 plus what? N. Is it not? So when n is 10, let's go. 2 raised power what? 10 minus 4 plus 1 plus 10. 2 raised power what is this? 6 plus 1 plus 10. What 2 raised power 6? 64 plus 1 plus 10 is what? 75. 75. To take if your answer is correct, do you know how you take? Let's add up from year to year. You must have, I think so, 75. Let's check. I think I've done that before. Add this 1 plus 1 plus 1 is what? 3, Abi? 5. 20 plus 18. 40 plus this. Is it correct? So when you add up this, the result is what? 75. That will show you how accurate your answer is. Okay? Find the isomers of the following compound. Find the isomers of the following alkane. Number 1, propane. Number 2, butane. Number 3, pentane. Number 4, hexane. Alright guys, find the isomers, meaning bring out all the isomers of this compound. The first 3 members of alkane has amino isomers. 1. Propane fall under the first 3, right? So propane has amino isomer, 1 isomer. Please pay attention. For propane, this is, okay, let's check. Propane has, number of carbon is what? 3, Abi? We have 1, 2, and what? And 3, is it not? Is it not? Huh? Are you following? So this is propane. This is propane. The isomer of propane is called N-propane. It's called what? N-propane. We call this what? N-what? Propane. That is the only isomer. Propane itself is the what? An isomer of what? Of itself. Are you there? Propane is what? An isomer of itself. And it's called what? N-what? Propane. Do you get the concept? There's nothing, I can't do it, I can't create a branch here. Do you get? I can't remove this and put it here. I'm still forming what? The longest what? Chain. Is it making sense? Number one is this, right? Number two, what do you have in number two? Butane, Abi? Butane. The what? Butane. Butane is when N equals what? 4. That means we have how many carbon atoms? Let's check. 1, 2, 3, and 4, right? I hope you are following. Butane has how many isomers? From the table. Okay, 2. I know I gave you that table, so you know how to manipulate your way through. Look at this. The first isomer of butane is called what? N-butane. N-what? Butane. The first isomer of any alkane is N-alkane of that compound. If I have hexane, is what? N-hexane. Are you there? So for this, the first, this is called what? We call this what? N-what? Butane. Now, how do we generate the second isomer? How? Is by creating a branch. I can remove this carbon atom here and place it here. How many carbon do we have here? 4. To generate the second isomer, I'll look for a means to reduce the number of carbon and create what? A branch from there. That means there becomes what? 1, 2, 3. Is it not? Where will I place the second carbon? Will I put it there? No. If it's there, it means I'm still creating what again? N-butane. Don't forget that. You cannot put a substituent in the last carbon. Are you there? It must be in the second or third or fourth, but not on the first and last. So where? What will it be? CH3. And this will give us what? Hydrogen, 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 and what? Hydrogen. So what do we call this compound? 2 what? 2-methyl-propane. Therefore, the propane. Therefore, the isomers of what? Butane, Abi? Is what the first one? N what? Butane. Second is what? 2-methyl-pro what? Propane. Is it clear? Are you following? Are you following? N-butane and 2-methyl what? Propane. So this is N-butane. Which is this? Sorry, N-butane. This is what? 2-methyl what? Propane.